Okay, now I am audible to all the students. Please reply in the chat box. Yes, sir. Okay, fine. So, dear students, today we are starting with the first chapter of the subject, that is basic mechanical engineering. The subject name, that is introduction. Kindly note that this is a very interesting chapter and the simplest chapter of the subject of basic mechanical engineering. And friends, whenever you are preparing this subject for the examination, never skip this chapter of introduction, because the points of this chapter are very easy to understand. You can score good amount of marks by attempting the questions from this chapter and writing the answers perfect. There are no numericals in this chapter, and also there are no practicals in this chapter. And friends, in the first chapter of introduction, majority of the points you have already studied at your school level. So let us proceed with the discussion of the current session. So friends, these are the main contents of this session. We are going to discuss the concept about the prime mover and its classification. Also, we will understand what is mass and weight. I hope that seeing these topics, you might be getting the idea, sir, we are knowing some of the points related to these topics. So as and when the topics are coming, I will be asking you some of the questions and there will be the interactive session. Next, we will understand the force and the effects of the force. Then we will understand the pressure and the different types of pressure. We will understand the concepts about the work, power and energy. And finally, the last topic of this session will be the law of the conservation of energy. So let us proceed with the discussion. So the first topic, that is the prime movers. And friends, kindly note this point. The topic of the prime movers is one of the most important topic which is generally asked in the theoretical examination. The question which is asked in the theoretical examination of the university, that is what is prime movers and what is the classification of the prime movers. One of the easy question which is asked in the theoretical examination. So this topic is very important. So we will understand this topic perfectly so that the concepts are clear, and whenever asked in the examination, you can easily note down the answers and get the maximum marks. So prime mover, as you are seeing in the pictorial representation, the prime mover takes in the energy from the natural sources. Natural sources are those sources which are available from the nature. If we want to give some of the examples, examples are the coal, petroleum, natural gas, etc. They are the natural sources. So prime mover uses these natural sources, converts the energy of the natural sources into the mechanical energy, and this mechanical energy can further be converted into the useful work or the shaft power. Dear friends, shaft is a mechanical component which is used for the power transmission. So basically, understanding the pictorial representation Now we are going to give the definition of the prime mover. So prime mover is a device which uses the natural sources to convert their energy into the mechanical energy or the useful work or the shaft power. So friends, in the prime movers, basically the output of the prime mover that is fixed. At the output, we will be either getting the mechanical energy or the useful work or the shaft power. But we can change the input of the prime mover. We can provide the coal to the prime mover, we can provide the petroleum, or we can provide the natural gas or some other natural sources. So prime movers definition I am repeating once again because it is one of the most important point considering the examination. So prime mover is a device which uses the natural sources to convert their energy into the mechanical energy or the useful work or the shaft power. Proceeding further with the discussion of the prime movers, the prime movers are considered as the primary or the elementary sources for the production of the mechanical energy or the mechanical power. The energy which is produced by the prime mover is further transmitted to some other mechanism or the machine. The machine or the mechanism or the linkage that transmits the mechanical power developed by the prime mover is called the drive. So these are some of the mechanical approaches or the concepts in context of the prime movers. So friends, from this particular topic, we need to understand perfectly the definition of the prime mover. I hope the definition is much clear and now you are confident with the definition of the prime mover. Proceeding further with the next topic of the prime mover, that is the classification of the prime mover. Okay, so I'm getting some of the questions in the chat box. Dear friends, let me instruct you. At the end of this session, we'll be having the doubt solving session. So you can just note down your doubts in one of the paper or the notes which you are writing. And in the doubt solving session, we will be solving all your queries. Okay, so it will be more convenient so that the other topics are not disturbed during the lecture. So proceeding further, and again one of the important topic, that is the classification of the prime movers. I had already told you that the output of the prime mover is fixed. That can be either the mechanical energy or the useful work or the shaft power. But we can change the input parameter. So the classification is done on the basis of the types of the energy sources used by the prime movers. Basically, on the basis of this parameter, the prime movers are classified into two types: the thermal prime movers and the non-thermal prime movers. The thermal prime movers, they are related with the context of the heat energy, whereas the non-thermal prime movers, they are not related with the heat energy. So proceeding further with the classification, that is the thermal prime movers. The thermal prime movers are further divided into 5 subtopics, that is the fuels. The examples are the heat engines, and heat engines are one of the important mechanical devices or the systems for producing the mechanical power. In the heat engines, we are using the fuels. We are undergoing the process of combustion or the burning of the fuels, and likewise we are producing the mechanical energy. So on the basis of the type of the combustion of the fuels, the heat engines, they are further classified into two types, that is the external combustion engines and the internal combustion engines. Names are self-explanatory. External combustion engines, in this type of the engines, the combustion of the fuel takes place outside the engine cylinder, whereas in the internal combustion engines, the combustion of the fuel takes place inside the engine cylinder. And the automobiles which we are using in our day-to-day lives for the transportation purposes, majority of the automobiles, they are using the internal combustion engines. The next classification of the thermal prime movers, that is the nuclear energy. Nuclear energy is also used for producing the mechanical energy or the useful work, and the examples are the nuclear power plants. Next comes the geothermal energy. Geo, that is the earth, and thermal, that is the heat energy. So the energy, heat energy, basically obtained from the earth's crust, that is known as the geothermal energy. So using the geothermal energies in the thermal category, the examples are the geothermal power plants. The next type is the biogas energy. The examples are the biogas plants or the natural gas plants. In simple terms, we are knowing it as the gobar gas plants for producing the CNG, etc. And final category of the thermal prime movers, that is the direct solar energy. And right now we are seeing that with the advancements of the technologies, we are developing several mechanical systems which are using the solar energy as the input parameter, and finally we are generating the useful work. So this is the wide classification of the thermal category of the prime movers. This category mainly, as you have understood in the names, they are concerned with the heat energy. Proceeding further with the next type of the prime mover, that is the non-thermal prime movers. Here we are having three names. They are the hydel energy, or can be considered as the water energy. The examples are the hydropower plants or the water power plants. You have heard the name, that is the Statue of Unity, the Sardar Sarovar project, that is one of the example of the hydropower plant. Next is the tidal energy. Because of the movement of the tides and the apes in the oceans, we are rotating the mechanical turbines and thus we are producing the power. And final category, you are well aware about it, that is the use of the wind energy, and the examples are the windmills. The windmills are producing the mechanical energy utilizing the speed of the wind. So friends, this is about the topic related to the classification of the prime movers. One of the most important question which is generally asked in the theoretical examination. What is the definition of prime mover? Give the classification of prime movers. I hope you are getting the points which I am discussing. Let us proceed further with the next point, that is the mass and the weight. I hope the terms you are familiar with. So let me ask you the simple question. What do you understand by mass, or what do you understand by weight, or what are your comments related to the mass and weight? You can share your comments or share your views in the chat section about the concepts of the mass and the weight. Okay, mass is the amount of matter in the given object. Okay, mass is the measure of inertia. Very good answer. W, that is equal to mg. Mass is the amount of matter. Okay, very good answer. I want some more answers. Mass is the measure of the amount of matter. Okay. Weight is the force on the mass. Okay, somewhat we are partially right. Rule number 9, Vishal Sahu. Weight is the gravitational force. Okay, weight is the force applied. Weight is measured in newtons. Okay, so seeing your responses, I hope that you are clear about the concepts. So let us have the refreshment of the concepts of the mass and weight by giving the simple comparison. So definition, mass, you are already aware, it is the amount of matter contained in the body, whereas the weight is the amount of force which is acting on the mass due to the acceleration due to gravity. Here friends, we need to consider the acceleration due to gravity, and weight is a type of force. If we consider the notations, mass is denoted by small m, weight is denoted by W. Type of quantity, the mass is considered as a scalar quantity. The weight, since it is a type of force, it is a vector quantity. Formula for finding the mass, that is equal to volume into density. Formula for finding the weight, that is the mass into the acceleration due to gravity. Remember friends, this point very important for the weight. In the weight, we need to consider the acceleration due to gravity. SI unit for the mass, that is kilogram kg, whereas the weight, it is Newton, denoted as capital N. Important feature, mass does not depend on the gravity, it is constant everywhere, whereas the weight, it totally depends on the gravity, and so it varies from place to place. So these are some of the basic concepts related to the mass and the weight. Moving further with the next interesting topic, that is force. Before starting the discussion of the force, let me again ask you one of the simple question. Which law of Newton gives the definition of force? Which law of Newton gives the definition of force? Some of the students are telling second law, some of the students are telling first law. Okay, second law, first law, second law. Okay, second law. Okay. So here in this particular question, I am getting some mixed responses from the students. So let me give the correct answer. Dear friends, the definition of the force is given by the second law of the Newton. So let us understand some of the basic concepts related to the force. The force can be considered as a push or pull of an object. It is considered as an external agent which is capable of changing the state of rest or the motion of the body. As you are aware that force is a vector quantity, so for the studying of the force, we need to consider its magnitude as well as the direction. The quantity of the force is expressed by the vector product of the mass and the acceleration. If we consider the mathematical equation for the force, then it is expressed as force is equal to m into A. And friends, now if you consider this equation was given by the second law of the motion of the Newton. So the definition of force is concluded from the second law of the Newton. In the equation, m represents the mass of the body, that is in kg, a represents the acceleration of the body. If we consider the units of the force, in the CGS system of the units, the force is expressed in dyne, whereas in the standard international system of units, that is the SI units, the force is expressed in Newton. You are well aware about it. And if we consider the larger units of force, it is the kilonewton and the meganewton. So friends, again one of the simple question I would like to ask. 1 meganewton is equal to dash newton. 1 meganewton is equal to dash Newton. Fill in the blank. Okay, I'm getting the responses 10 raised to power 6, 10 raised to power 6, 10 raised to power 6. Okay, very good. Perfect answer from majority of the students. And here there is no confusion. All the students are giving me the perfect answer. Very good, very good. Proceeding further with the next topic of the force, that is the effects of the force. I am giving you some of the pictorial representations of the effects. You are already well aware about the different effects of the force. The first image, that is showing a man using a force to move a stationary lawn mower for the gardening purposes. A footballer uses a force to change the direction of motion of the ball while playing the football. The cyclist uses a bigger amount of force to pedal his bicycle and increase the speed. A baker uses a force on his dough to shape it into a curry puff or to give a particular shape. So these are some of the effects, simple effects of the force. You can also add some more effects. You are quite aware of it. So I hope you are getting the points which I am discussing up till now. You are getting the points which I am discussing, and I expect that this is a somewhat refreshment because you have already studied the concepts. Okay, I'm getting some of the positive responses from the students. Very good. That means you are understanding the concepts. Very good. Proceeding further, the next topic, that is pressure. Dear friends, pressure, one of the most important term considering the mechanical engineering and this subject. In several other topics, in several other chapters, we will be using the concepts of the pressure. So try to focus, try to understand the points which I am discussing in this topic. So pressure in general sense, it is the force applied perpendicular to the surface of an object per unit area over which that force is distributed. Considering the definition of the pressure, we can simply write down according to the definition. Pressure is equal to force upon area. Thus, we can consider in terms of notation, P is equal to F upon A. For better understanding of the pressure, two images I have shown. In the first image, we are seeing the larger dimensions of the wooden block. So applying the force on the black box, the pressure taken by the orange box is comparatively lesser because of the larger area of the wooden box. But when we consider in the second case, we are seeing that the area of the wooden box is comparatively reduced. So applying the same force on the black box, the yellow box will be having high amount of pressure. These are very simple and fundamental understandings related to the pressure. So understanding this example of the pressure, I can tell that the pressure between the two solid surfaces depends upon the two things: the force between the surfaces, the area of contact between the two surfaces. And the final statement is very important in context of pressure. The greater the force or smaller the area, the greater is the pressure. Dear friends, you can note down this point or try to remember the final statement of the pressure because it will be used in the further topics of this subject. The greater the force or smaller the area, the greater is the pressure. Proceeding further with the discussion of the pressure, the next point, that is the units of pressure. There are several units of pressure. The first unit, that is PSI, pounds per square inch. The next unit, that is bar. So 1 bar equals to the atmospheric pressure on the earth at the sea level. The next important unit, that is Pascal, and 1 Pascal equals to 1 Newton per meter square. Remember this point, or you can also note down this point. Also the unit of pressure, that is the inches of the mercury. Torr is also one of the unit of pressure, and inches of water is also considered as a unit of pressure. Here friends, in the bottom you are seeing I have highlighted one of the point and written remember. So kindly note down this point, or if you want to remember, then remember this point, that is 1 bar is equal to 10 raised to power 5 Pascal or Newton per meter square. Because friends, whenever we are solving the numericals in this chapter, in majority of the numericals you will be given the pressure in terms of bar. So for doing the calculations, we need to convert the bar into the Pascal. And for the conversion, we will be using this equation. So I hope you are getting the points, and you can also note down these. Remember, that is 1 bar is equal to 10 raised to power 5 Pascal or Newton per meter square. Moving further with the next topic of the pressure, that is the types of pressure. Dear friends, there are 5 different types of pressure. The first one, that is the gauge pressure. The gauge pressure is a type of pressure which is measured by an instrument known as the pressure gauge. Pressure gauge is one of the device or the instrument which is used for measuring the pressure. And the pressure which is measured by the pressure gauge, that is known as the gauge pressure. So it is very easy to understand the definition. Proceeding further with the next type, that is the atmospheric pressure. The name justifies the definition. The pressure which is exerted by the atmospheric air, that is known as the atmospheric pressure. Next comes the standard atmospheric pressure. So it is the atmospheric pressure which is being influenced by the atmospheric conditions on the Earth's surface at the mean sea level. So for calculating the standard atmospheric pressure, we are using the mercury column. I hope you have heard previously that for the pressure we are using the unit, that is the 760 mm of mercury, or in simple terms 760 mm of Hg. That was considered as the standard atmospheric pressure. The fourth type of pressure, that is the absolute pressure. The absolute pressure is the summation of the gauge pressure and the atmospheric pressure. And the final pressure, that is vacuum. Vacuum is also considered as a type of pressure, and it is defined as the pressure below the atmospheric pressure. So whenever we are moving in the negative direction of the atmospheric pressure, then we can tell that we are moving towards the vacuum conditions. And for measuring the vacuum as a type of pressure, we are using torr as the unit. So these are the 5 different types of the pressure. Moving further, the next interesting topic, that is the work. You are well aware about this term. Work refers to an activity involving a force and the movement in the direction of force. So a work is done on an object when the force acts on it in the direction of motion, or the component in the direction of motion. Mathematically, work is equal to force into distance moved in the direction of force. The work is generally measured in terms of joules. So that is J is equal to Newton into meter. Very easy to understand. Next concept, that is power. So power is the rate at which the work is done or work done per unit time. Mathematically, power is equal to work upon time. Standard units Newton meter per second. Also the power is expressed in terms of watt. When we consider the automobile engines, we are using the power, that is horsepower, and 1 horsepower, that is equivalent to approximately 750 watts. So this is some of the basic understanding related to the power. Moving further with the next topic, that is the energy. Energy is the capacity of doing the work. So energy is very much necessary to accomplish the work. This is a very interesting statement. Energy is just like the currency for performing the work. Different forms of the energy or types of the energy, they can be considered as mechanical, nuclear, chemical, thermal, etc. Also, you can name some of the few types of energy. Now the topic, types of energy, this is important. So try to understand this point. The energy is further divided into two types, that is the high grade energy and the low grade energy. High grade energy is that type of energy which is completely converted into work. Now friends, considering the engineering perspective, we cannot have the total conversion. Always there will be the losses coming into the picture. But when we are considering the high grade energy, this is an important point to be considered. In the high grade energy, we are neglecting the losses. And since we are neglecting the losses, now we can tell that the energy can be completely converted into work. Some of the examples of the high grade energy are the mechanical energy, the electrical energy, or the wind energy. The opposite of the high grade energy, that is the low grade energy. Definition tells that only a certain portion of energy can be completely converted into work. That means in the low grade energy, we are focusing on the losses which are taking place during the conversion of energy into the work. Examples of the low grade energy are the thermal energy and the heat of the nuclear fission. So making these points very simple, try to remember in the high grade energy, losses are taking place, but we are neglecting those losses. In the low grade energy, losses are taking place, we are considering those losses. So this is the master key to remember the high grade energy and the low grade energy. Moving further with the next topic, that is the mechanical energy. Mechanical energy basically is divided into two types, the kinetic energy and the potential energy. Kinetic energy, I think that you are aware about it, that is the energy possessed by a body by virtue of its motion. That means whenever there is the body in the movement, we are considering the energy, that is the kinetic energy. And the expression for finding kinetic energy, that is Ke is equal to half mv square, where m is the mass of the body and v is the velocity of the body. One of the simple question, can any student give me the examples of the kinetic energy? Any student can give me the example of the kinetic energy in the chat box? Any student example of the kinetic energy? Okay, so I am getting responses, running turbine, moving car. Okay, fine. So that means whenever the body is in motion, it is having the kinetic energy. Good, I am getting some of the perfect answers, perfect examples of the kinetic energy. Proceeding further with the next mechanical energy, that is potential energy, the energy possessed by the body by virtue of its position or elevation. So potential energy is calculated as PE is equal to mgh, where m is the mass of the body, g is the acceleration due to gravity, and h is the height of the body. Some of the examples of the potential energy, that is the water stored in the dam, the rock on the mountain, the computer table on the computer or the desktop on the table. So these are some of the examples of the potential energy where we are considering the position and the elevation. So moving further to the last topic of this session, that is the law of conservation of energy. I think you have heard this topic. Energy can neither be created nor be destroyed. It is possible to convert one form of energy into another form of energy. And finally, the total amount of energy remains constant before and after the transformation. This transformation deals with the conversion of energy into work and also can be considered as work into energy. So these are the three important statements which are compiled in the law of the conservation of the energy. So friends, with this, I am concluding the session from my side. Now the session is open to you. So till when the meeting is going on, I will be happy to share your doubts. So the questions from the current session are welcomed from your side. You can send your question in the chat box so that I can clear your doubts. Okay, sir, can be considered mass as a type of energy. Mass is the quantity of the matter. Okay, that can be considered as a type of energy that we'll be discussing in this chapter only. That is a type of the energy which is known as the internal energy. Dear friend, just wait for some time. This I'm going to cover in the current chapter only. Sir, where is external please explain absolute pressure again. Okay, absolute pressure in simple terms, it is the summation of gauge pressure and atmospheric pressure. It is the addition of gauge pressure and atmospheric pressure. Why we neglect the losses in the high grade energy? Because finally in the high grade energy, we are totally considering on the output of the energy. Hence, we are getting more amount of the output in respect to the losses. So, since the losses are negligible, we are neglecting those losses. So, that is the concept of the I